This is No Nonsense Leadership, where we explore better ways to develop software products and services. Join world-class experts for honest insights and practical advice to help you lead digital teams clearly and confidently. Subscribe now to learn the best ideas in the field.
In this episode, we talk to Bryan Finster about test-driven development. We discuss what TDD is and why it's essential for high-speed, high-quality software engineering. Bryan criticises independent QA teams, and we explore how integrated, cross-functional teams provide the rapid feedback you need to develop high-quality code. And we discuss how to use value stream mapping to show your leaders the need to make a change. Tune in to learn all about TDD and BDD from an expert. Welcome to the No Nonsense Leadership Podcast. I'm Murray Robinson.
And I'm Donna Spencer.
And I'm Bryan Finster.
Hi, Bryan. Thanks for joining us today.
Sure.
We would like to talk to you about test-driven development, but why don't you introduce yourself to the audience first?
So I've been a software developer for about 3 decades, mostly doing it incorrectly. Lots of pain, lots of late nights, multiple days in a row a week. And then later figured out that doing it correctly means I work less, get more done, and I'm on a happier team. So I'm very shouty about it because every team should be happier, and I don't want to wind up on a team where they're not working that way.
And you've worked for some big, well-known organizations.
I was at Walmart for 19 and a half years. Before that, I worked for a supply chain provider in Dallas, Texas. And now I work for Defense Unicorns, where we're trying to help enable continuous delivery in some very challenging Department of Defense environments.
Yeah, I bet. So we've been having some discussions with people on LinkedIn about test-driven development. What is test-driven development? Is it just testing?
Well, if you're doing real test-driven development and you're writing a failing test and then making it pass and then refactoring the code to clean it up because your code's ugly, and that's that red-green refactor cycle, the outcome of that is your code becomes more modular and testable. So the act of doing test-driven development does drive better design at the low level, or sometimes even higher level. The problem that I see a lot of people have with test-driven development is all the examples out there are very small, very contrived, and very focused at one function, one method. The way I learned how to do test-driven development was from the point of view of we need to get better requirements coming in so that we could actually do continuous integration, because for CI to happen, the tests have to go into the version control at the same time as the code. So you don't have to do test first, but you have to at least do test during development. And so to solve that problem, we started doing behavior-driven development. Now, if you go and read Dan North's material, he created behavior-driven development because people didn't understand that test-driven development wasn't testing units of code, it was testing units of behavior. And so he was taking it up a level to pull people away from JUnit so they could focus on what they were actually trying to do with TDD. The way I think about tests is a higher level generally. I will go do unit tests some, but I'm mostly testing strings of behavior put together.
I might respond to you in the way that I saw people responding to you on LinkedIn. So we already do unit testing. So we're already doing TDD.
I don't argue about are you doing TDD or not. I don't argue if you're doing trunk-based development or not. You're doing continuous integration or you're not. If you want to do continuous integration with 7 merges because you're using Git flow, fine, I don't care as long as you're integrating code at least daily. Test-driven development, I want the tests to be co-located with the code in the same commit. Now, if you want to write the tests afterwards, you're going to wind up doing a lot of rework. I always suffer when I don't write them first because I haven't actually sat down and thought about what it is I was writing. And I have to go back and do a whole bunch of rework because I didn't do the test first. But if you want to do that, I'm fine with that, as long as you commit testing code. Why do I need a human to go and manually do that crap after we decided what we were going to do?
Yeah, but testers will say developers only test a very narrow piece of functionality. And what testers need to do is test all of the rainy day paths. Developers never think of that. And also developers never think of integration. And so we have to do all the integration tests because developers never think about that.
Yeah, and so testers only know how to do giant end-to-end flaky tests with a whole bunch of terrible data setup that's always failing. People will test what they're incentivized to test. It comes down to leadership. If I have no responsibility for the outcomes of my decisions, then I have no pressure to help drive quality. I need rapid feedback that things are going south so that I can increase my quality. But if I'm a developer and I'm not being incentivized to test at all, I'm not going to because you're not paying me to, you're not asking me to, and it's just a lot of work. Besides, you're probably structured in a way so somebody else feels the pain. So why do I care? Other than now you've got a test team that's judging me about how many defects they find. But those aren't the real defects. The real defects happen in production. And again, you have a support team that's handling all that pain. So why do we care? But if I'm going to get woken up, I care a lot. I know, because I've carried a pager for 20 years.
But Bryan, this sounds really expensive because you're asking the developers to slow down to write tests.
God forbid we know what it is we want to develop before we start coding. We should immediately just jump in and start coding and say, is this the rock you want? The thing with behavior-driven development that was so powerful was we could sit in a meeting and decide not to code something. How much money did we save because we wrote down a scenario and then crossed it out?
We have our testers come in after development. Are you saying that they're going to come in before development starts? That's going to cost us so much money. What are they going to do?
When I was first learning how to do this, we saved a crap ton of time because we decided up front what it is we were going to test and how we were going to test it. And then instead of having one person go out and implement the tests or offshoring it to a bunch of test automators someplace that had no context, you had the whole team who understood the context of what we were trying to deliver, implementing the tests, implementing the code reviewing each other, improving the tests, and then delivering at a rate that most teams think is impossible. When I left that team, the cycle time starting to work on a new task to delivering to production average was 0.89 days. And that was in production, running, with a very high success rate.
What was the start of your cycle?
You've got a refined piece of work ready, picked up off the backlog.
Okay, yeah, that's good. I've worked for organizations where they have somewhere between 12 weeks and 5 years for their cycles.
Oh, yeah. Well, the total lead time originally was 12 months. And we got the lead time on my team from request to delivery down for 1 or 2 days.
Yeah. So my understanding of writing the test first is that you're combining it with writing the requirements. So effectively, you've got a feature or a story or something you want to build, and you're writing testable requirements. So there's no separation between the requirement and the test. It's the same thing.
The tests are the requirements if you're doing this correct. You're talking about what it should do, what it shouldn't do. When you're just laying out those functional tests, you may not get into all of the different technical failure modes. But yeah, you've defined what it is going to do before you start doing it with something that's not just like vague, some wish list that someone put together that they don't even know if it's possible or not.
So we've got some sort of business stakeholder or product manager or product owner who is communicating the business priorities to the team. Then a couple of people in the team say, what is this? How are we going to do it? And how are we going to test it?
Let's talk about what used to get it wrong. Have a product owner go and write a whole bunch of Gherkin.
A whole bunch of what, sorry?
Gherkin's a domain-specific language for behavior-driven development. So it's the given when then. There's parsers out there who will parse Gherkin and generate test stuff. But BDD is not the automation. If you start with the automation, you're doing it wrong. BDD is a piece of paper and brains with pencils. So one way to get it wrong is you go out and have a product owner go and just write up a whole bunch of stories with scenarios, or assigning stories to a QA person who will write a bunch of scenarios. It's wrong. The power of this isn't just the tests, it's also getting people onboarded into the domain, into the problem space. So we pull those 3 or 4 people together, and we pull the scenarios up to about 70%. Pretty good. And then we come back with the whole team. Having 15 people stare at a blank sheet of paper is not very effective, but having 15 people come together and edit is. It's like being in the writer's room for a movie. So we come in, we pull it up to the point where we all agree any of us could pick up any one of these scenarios and get it done in 2 days or less. And that meant that everybody had context on all the work. That meant code review is more effective. That meant that when we were doing tests, we could compare it to the scenarios we said we were going to test, instead of just picking up a code review and having no context at all.
So just to be a bit more concrete for people who don't understand given, when, then.
So it's given this current state, when I perform this action, then I should see this outcome. And as soon as you start putting implementation details like press button or display on, you're doing it wrong. Liz Keogh will tell you to pretend that magic pixies are doing the actions. There is no system. This is what I'm going to see. Now, the power of this is you can write this at any level. So you can write this down to, this is what this function will do, all the way up to this is what this service will do. When I worked at Walmart, Paul Hammond was given a workshop on behavior-driven development. He just wrote down the feature title and started diving into the acceptance tests. And somebody said, what about the user story? He said, we've got these acceptance tests here. We have this description of the feature. What's the user story for? I don't see any value in user story. I'm not going to go there. We've already talked about what we want to do.
I've seen them combined. So people tend to put a lot of detail in a user story. They don't need to put it there. They can put it in the given, when, then.
Yeah. The only point I'm trying to make is do something because it adds value. If you're doing something because you're supposed to do it, don't do it.
So in your context, are you putting examples like data?
So it depends on the kind of feature you're building. If the feature is data heavy, you need that to show it's going to behave this way with different sets of data, then yes, you put data tables in there and say, with this set of input data, it should come out like this.
If we are actually going to automate a test, though, we've got to have some data so we can get some outcomes and check those, don't we?
It would be helpful. But anytime I'm writing a test, I'll bring in something I can control where it's always the same input. What I don't want to do is have random state, because you can't control anything if you just have a random set of data. Especially if you're trying to do negative testing, you need controlled sets of failure scenarios that you can go and validate the failure triggers the right outcome. And so I'm very careful about how I manage state. A test is an experiment, and you have to control your variables. I remember one time, my team was just one component of this giant system. And the QA team, it went in an end-to-end test of all the products chained together. So you're going to receive a purchase order, and then you're going to invoice something to a warehouse. So you do the entire warehouse distribution process as one end-to-end test. And so what happened is they would go through and hit one of the products, and they'd have some data problem. They'd fix the data issue, and then restart the test from there. And they'd shut down all the teams for 4 hours while they were doing this. I told the head of QA I was never participating again because that was not a test. Because you were just correcting data when it broke and then continuing so you can say you did an end-to-end test. And that was garbage.
We've written given, when, then just in words, maybe with a scenario in the context. And then we're going to automate it through a tool like Cucumber or Gherkin or Asterisk.
My experience has been that tools like Cucumber don't necessarily help. Just use your unit testing framework. You don't need to pull in an entirely different framework and figure out how it's wired in. When I first started doing this, we were using Cucumber for JavaScript, and it was causing all sorts of test instability. Just use your XUnit framework. You can do the same thing with that. The main thing is understanding I have to set up this data, I have to perform this action, I have to assert this outcome, and keep that in your head. If you want to, you can write the tests that way in that framework, but you don't necessarily have to. And these days, when I'm planning out what I'm going to test, what my requirements are, I just write it should, and then go from there.
So who wires it up? Is this the first step that the developer does when they pick this up?
So if we're doing this correctly, the task the developer will pick up will have the acceptance tests in it. along with any interface changes defined with the contract test for those interfaces. We don't want vague descriptions in the contract either. And then it's just implementation because they know exactly what this thing is supposed to do when they're done.
Yeah, but do I need a test automation specialist to wire up my acceptance tests?
No, but what you do need is the skill on the team to refactor the tests, to understand when we might need to pull tests up to a higher level, but also trying to drive tests as low as you can. I will write these sociable unit tests. They're actually bigger than a unit test because they're testing a business flow and not just a smaller unit of behavior. But I won't cross a network boundary without a fake database or a virtual service because I need to control that variable. I am testing it at a higher level, but I also have to consider the speed of my pipeline. Can I get a test to run really fast because it's covering more in one test and give me the same level of confidence versus a whole bunch of smaller tests that run slower because there's more testing happening? How do I architect the level of confidence I need with the highest level of speed I can get? Because feedback speed is so important.
All right. So to summarize, the team together has prepared a definition of the thing that's going to be built. And that definition is given when then acceptance test interface contracts or agreements. Then the developer starts wiring up the test and then they write the code to pass the test and they're checking as they go.
Yeah, I've got my acceptance tests and I'll write just the stubs for the acceptance tests. So they'll be skipped. And then I'll go implement the test, write the code, implement the test, write the code. And I'll just solve each test where all the tests are done when I'm done with my task. And also, if it's a big thing, we should be breaking that up into multiple commits and multiple code reviews because large deltas are very difficult to code review. Let's say that I've got a task and I've got these 4 small scenarios. Each one of those scenarios has got 6 lines of Gherkin in it, maybe. So those are 5 or 6 individual tests or sub-tests. I would implement a scenario and then integrate that to the trunk and then go to the next one. And so I have these very small things being integrated into the trunk all the time.
Yeah, so I'm integrating my automated test as well as my code that passes the test into the production code base.
We're doing continuous delivery. Until someone shows me a better way to deliver software than CD, CD is the correct way to deliver software. For CD to function, the CD pipeline has to do its job. The job of a CD pipeline is to fail code. It's not to deliver it, it's to fail it. And if I don't have the tests with the code, it can't fail the code.
Yeah. I know when you're coding, you're actually doing a lot of learning. You start going through it and you go, well, that interface contract isn't what is in the interface, or that acceptance test is missing this thing, or this thing is much bigger than 2 days worth of work. Or I don't understand the UI design. I think that doesn't make any sense.
If we're making those discoveries during implementation, we should have a discussion about it because there's a problem with our quality process that we need to fix.
Yeah, but it happens all the time, doesn't it?
It happens much less once you get good at it. We had a rule that if you had to ask a question after picking up a task, we were going to have a retro about it right then. We weren't going to wait till the end of a sprint. We're going to have a retro about it right then. What do we do better next time? So we just do a postmortem of why it is you had to ask a question, and then we go forward. So it's relentless improvement. And eventually you get to a point where we just very rarely have to ask questions anymore because we are so good at refining the work up front that it's just implementation detail.
There's a bit of a tension there between how much you do up front versus how much you let people learn as they code. There's quite a lot of people in the Agile community who would say just define it broadly up front on the expectation that people will communicate and learn as they code.
They're wrong. The job isn't learning something while coding. The learning is supposed to happen after you deliver because the tension we have isn't between how much upfront work we do and how much we learn when we code. The tension is how much upfront work we do that we don't know for sure is the right work versus how much we deploy. And so you are refining just enough to get something out there so you can get feedback whether this is even a right idea. The idea is what we should be ultimately testing. If developers are constantly learning while they're coding, then we're not effectively getting feedback on the idea. And the main thing we care about is speed of feedback of whether we delivered the right thing.
My assumption is that there's always some aspect of the requirement, the design, the technical design that is wrong, and we don't know about it until we're doing the work and getting people to use it.
Some of the testers I've talked to claim that if you just give it to them for long enough, they'll find all those problems. You can't find a wrong idea. You can find where the user experience isn't optimal, but you can't find we solved the wrong problem by testing it harder.
Yeah. But we've made assumptions. We might not even know that they're assumptions, and we don't discover it until later.
I wrote a blog post called The Three Wrongs, where I boiled down the problem we're trying to solve to the requirements are wrong, or we will misunderstand them during development, or they'll change before we can get them out there. It won't be really what was needed. And the user changed their mind. Or once they saw it, they're like, oh, no, that wasn't what I really wanted. It's what I meant, but it's not what I really need. And so your goal is to get good at shortening the loop of finding out which one of those things is wrong. Now, interestingly, the people that argue you need a independent testing team to do adversarial testing. Now you have two teams that are going to have the incorrect interpretation of the requirements. So now you're twice as likely to misunderstand it. So now you've got 4 wrongs instead of just 3. Plus a triage process to go and figure out who's wrong. And this is not hypothetical. I've measured this on multiple teams where they literally have a triage process to find out if the test team is wrong or the dev team is wrong, only to find out they're both wrong. When they talk to the product owner and get the correct answer and then deliver it, then the solution's wrong. And you can measure this.
Yeah. So what I'm hearing is that the way to do your learning is to reduce the amount of coding you do down to 2 days so that you can learn quickly by actually having something to see whether it works or not.
So the 2-day thing was something we came up with because we were trying to solve multiple problems. And these days, I try to go a lot faster than that, but we were trying to solve the business wanted accurate requirements. I can't estimate more than 3 days. I've had to do customer estimations for most of my career, and I cannot reliably estimate more than 3 days. We wanted to make sure we knew on a big team like that someone was struggling because people weren't always going to raise their hand and say, help me. And if you have a 5-day chunk of work, then we'll probably find out after 8 days that you have problems. But if you have a 3-day chunk of work, we'll find out after 3 or 4. And we also wanted smaller units of work so we could get better at code review and CI.
Donna, you come from a user experience research and analysis perspective, which is a lot bigger picture than that, bigger user flows and so on. Do you see any issues from a UX point of view?
When I've worked with teams who do the analysis and thinking part of this well, the UX person will be like, how do those things connect together? And I've found that this makes any detailed design a lot better because you know what the requirement actually is, like all of the ways it can go wrong. So you remember then to do error messages and your outflows and your different states in your modals. You also have data to work with. And as a designer, you need to work with data. And I see too many designers kind of design hand-wavy abstract things that are stupid because they don't deal with the constraints of real data or what's missing. So to me, this is a really good process, but I am a more analytical designer anyway. And like a product owner, there's another part of your job, which is to hold the whole system in your head and to add that context into the user story. So to me as a designer, I love when this all works well because the thinking is pushed further up front. And I think that when you pick up that story to develop it, it also should have guidance for the developer. Like, this is the exact screen on Figma that has all the bits that you need so that you can go pick that up
You also get faster feedback on those components of that design as they get delivered, that you can start playing with them and you can start tweaking that design because you had an idea, but it's different when you start playing with it. It's a lot faster to start coding and implementation and showing the work than it is to go and automate it in Figma. We can just automate it in React, play with it, and then we can go and change it. Just give me the rough outlines and let's start collaborating together. And I don't need it pixel perfect, but yeah, the developer should have everything they need to start delivering and not have to guess.
Yeah, like the text for error messages and hints and all of that extra stuff that designers should be doing and often aren't when they're doing broad hand-wavy designs. If you've got all those states, they should be writing those error messages and they've got it all ready for you.
The user experience is important, but we only get that by collaborating together and then delivering it really quick to find out if our collaboration was correct.
I once worked with a really highly skilled software development team, but I found that they lost track of the big picture and how it fitted together and the user flows.
It's so easy to get tied up in the technical details, but those don't matter. So my entire career, my focus has been solving business problems with code, not look how beautiful my code is. I want my code to be clean so it's easy to change, but other than that, I don't care how beautiful it is, as long as it solves some business problem efficiently and effectively. You have to be focused on the business problem you're trying to solve, so you don't go spend a whole bunch of money optimizing the code instead of optimizing for the business.
The problem we had in that team was that the product owner was absent most of the time. Also, we didn't really have a UX person. We had a UI designer, which is quite a different thing. And the business requirements had been made unnecessarily elaborate for all sorts of scenarios that weren't actually needed. So, yeah, there was a lot of confusion upstream, which led to these brilliant developers developing stuff that ended up being hard to use.
Value stream maps are easy to do and incredibly valuable. My team at Walmart used to do value stream maps when that was my job, was helping teams identify these systemic issues with the delivery flow. You value stream map the team's process and you go and find these things. Oh yeah, we've got all these retry loops. We're going back and asking questions to clarify, or oh yeah, we've got this huge backlog of user stories instead of just-in-time work, because you really want things to be just in time and not, we've got a huge backlog of refined work. That's terrible. All those user stories you've got piled up in your backlog have no value, and all they're doing is spoiling like milk in a warehouse.
Yeah. So you've done your 2 days work. When does the product owner review what you've done?
I guess it depends on how efficiently you want to run your organization. If you want to be very efficient, the product owner is always looking at the outcomes because they're on the team. They're looking at the latest build and they're just playing around in the staging area, looking at stuff as it's constantly changing.
I agree. Have them involved throughout, so there's no surprises. If you're going to have people do UAT, they're right there next to the developers.
I don't really believe in user acceptance testing. I believe in usability testing. I think that's something that the whole team should be doing it. The whole team should be playing with it, because it's not just up to the UX person to decide this feels weird. Any of us should be able to tell this feels weird because we're all understand how to use applications. And if you have UAT as a delivery process, then you shouldn't be doing that during an emergency as well, and you don't want to do that. So optimize your flow for emergencies. I'm writing a blog post right now about the supply chain of information, that undelivered change in the form of either story or code is inventory. It always costs money to maintain. You want the lowest level of inventory you can possibly get with the problem you're trying to deliver. And so if you're like, oh, every 2 weeks we review it, that's terrible. You're just batching up a huge amount of inventory, and let's risk that it's the wrong thing we're going to deliver. And so even if we can't deliver to production very frequently, we need to figure out some way to get a higher level of confidence that inventory won't spoil before we can ship it.
When I was a project manager for a telco, I asked Infosys to do test-driven development for me. And they said, yes, they could do that. That would cost me an extra $250,000. And they set up a team of QA automation specialists in India who were running Selenium over the code after the tests had passed to record the passing tests and then automate those in a very slowly running test harness. Now, what's wrong with that, Bryan?
There's so much wrong with it. Other than the fact that the people writing the tests had no context at all, there's the whole thing about those tests only test what it did and say what it's supposed to do. This is exactly the same problem we have with developers who learn how to write unit tests that are tied to implementation instead of behavior. They're not testing the behavior, they're testing implementation. And so you change something in that recording and the test fails. You can change the spelling of a button and now your test fails. Come on. It's important to remember that emphasis is motivated by taking your money, not by doing things correctly.
Their argument was that test automation is a specialist skill that isn't part of the regular dev team or test team.
Well, but their business model is hiring people directly out of college who are looking to get enough resumes so they can go work for Google. So sure, it's a specialist skill if your entire staff is based off of beginner developers that have never been taught on a test.
Yeah. And then their argument was you can't possibly automate a test until you know exactly what it's supposed to do. And you can't know that until you've written the code and it's passed through a manual test. Otherwise, it's going to change, Bryan, and then the automated test is going to fail straight away.
Yeah, I think we've already addressed that we have the conversation up front about what it's going to do. You make it so that the code is easy to change and the test is easy to change. You don't write spaghetti test code either. You treat the test code as carefully as you do the application code.
Yeah. Selenium tests by automating the user actions through the front end at a web browser. That's a problem, isn't it?
Yeah, through the browser testing is the worst possible way you could do testing. There might be some cases where you might need to do that for some reason, but for most cases, you can do any sort of front-end testing you need with an XUnit framework. You don't need to go through the browser. I'm not going to test a service by coming in through the API. I'm going to test the interface, and I'm going to test the behavior of the service, and I'm going to do all of those with lower-level tests. Why do I need to come in through the API?
Yeah. All right, let's move to how you might implement this TDD approach. And the first thing I always hear is, what is the tester going to do?
If they're in another team, I want them to work for somebody else. I actually had an Infosys test team in India assigned to me when we were doing this early on, while we were learning how to do continuous integration for the first time. And that Infosys test team was testing our service by manually inserting data into the database and then triggering some event through the API, and then when it would break, it was almost always because of data problems, because instead of using the service to generate data, which they could have done, I got my team so good at testing that every test failure is because their test was breaking. And so then I had QA remove them from my team. So you don't want an external person on testing. You want your team testing. You can either have somebody in a role of QA or just QA knowledge. It's exactly like product ownership. You don't have to have a product owner to have product ownership on a team. You just need to understand the business. But if you have somebody in the role of QA, their job should be to make it easy for the team to test and to make sure the team is testing well. They're your quality architect for the team. If they get bored, they need to write some code, they should pick up a feature, help deliver something.
Well, what about all those QA people who can't code?
Write requirements. Go and make sure that the logic is all sound.
Having a testing mindset is valuable. If there's claimed skills, they can understand how to solve business problems and how to do it in a way where it's not all happy path, then they should go be product owners and help teams prioritize and build out products correctly. I don't need anybody specialized in manual testing. Sorry, don't want it. It's slow. It's expensive. We have robots that can do that. For exploratory testing, you've got an entire dev team that can do that, including a product owner. Frankly, it's not a jobs program.
Yeah. So if I have a QA person in my team who is doing manual testing and they're cooperating well with the team, and I think they're quite good, would I ask them to develop the acceptance tests up front for each story, or would I get rid of them?
I would have them be responsible for teaching the team how to think about testing correctly. I'd have them drive the requirements refining sessions, because your primary quality process is defining what to do and what not to do. And I would put them in charge of partnering with the product owner. But if you draw a value stream map and you've got this one person who's manually testing before you deliver, then your throughput is 1. Doesn't matter how much coding you have, your throughput is 1. And it's an incredibly slow and expensive 1.
So should we have clear role specifications in teams, or should we just think about skills?
You need to build a team that has the skills you need. As soon as you start assigning dedicated roles, you start going, that's not my job. I don't want to step on their toes because that's their job. And how seriously is someone going to take the role of challenging somebody on how testing is being done if the testing is being done by a tester and that's not my job? So the role you want is team member, and then you want to build a team that has all the skills required to deliver what they're delivering.
All right. So how do we persuade our business stakeholders? Because they'll have the siloed test team saying, these guys are morons, don't do what they say, it's all going to be a terrible disaster. But we think it's a good idea. How do we sell it to the business people?
I would draw a value stream map, the process for delivering code or delivering a feature, and show where all the wait times are, the retry loops are. So you can tie that to hours, money. You can show, it's look, we have all these developers doing this, and then we have this bottleneck right here where all these developers are matching up work, and that's not like that work's not going anywhere. It's not work until it's delivered. Before that, it's just effort. You just talk about money. Don't use buzzwords. Don't use lead time and cycle time. Just talk about, see here where this person is waiting for 8 hours for this other person to do a thing before they can finish doing their thing. Just imagine the amount of money we're spending doing this. And see how in each one of them takes 4 hours, where we could figure out why it is we need 2 and get down to 1 and save 4 hours of salary. Or you see how we've got all of this work batched up here that's not earning any money because it's not production yet, because of all these other things we have in the flow that are batching up that work. Imagine if we could start earning money faster, or we could find out sooner it was the wrong thing. So you start talking business terms. I will always avoid any sort of agile or lean or any sort of conversation. No buzzwords. We're talking money.
Yeah. I have done a value stream map like that at a telco, and it was taking them 12 weeks to make a firewall rule change. And as you know, actually configuring a firewall probably takes 15 minutes if you know what you're doing. But let's say you got to work out what to do first, maybe a couple of days, but certainly not 12 weeks. And I mapped this out, and I was able to show that the process efficiency was about 2%. So the amount of time people actually did valuable work was 2% of the 60 days. People spent 500 hours on this, but actually only 15 hours of it contributed towards delivering something of value. So think about the cost of that. If it costs $100 an hour or $150, whatever it is in your organization, that's hundreds of thousands of dollars wasted.
I was showing one of my current teammates a value stream map from a previous organization I'd done, and the flow efficiency, so it was somewhere around 7 or 10%. And it took over 100 hours to deliver something. In only 12 hours, that was actually value-added work. And that's without the retry loops. That was best case scenario. So then you start throwing in retry loops with failed code review, or the test didn't pass, or whatever, and you have to go back and figure out why. And of course, the worst retry loop was an external testing team triage meeting. So it took 5 days to get an answer from a product owner if they had to go back to the product owner for the dispute coming out of the triage meeting.
The cost of those processes is quite incredible if you map it out. It's interesting that everybody focus on the developers. The developers are too slow. The developers need to speed up. We need to micromanage them with Europe.
We were using a metrics-driven approach to improving delivery at Walmart. And I've written a paper called How to Misuse and Abuse DORA Metrics.
Just explain the DORA metrics to people who don't know them.
Yeah, so in the last year or so, we've been hearing a lot about how do we measure developer productivity. The thing I keep reminding people on is that you need to measure the things that prevent developers from being productive, not measure how productive developers are, because developers are rarely the bottleneck, although that's where you want your bottleneck to be, is coding, but it rarely is. And so they're trying to measure how productive developers are instead of why is it that we're in meetings all the time? Or how often do we have to go back and get clarity on stuff? How much time are we spending waiting on things?
Yeah, or I built what you said you wanted, but then you didn't want it anymore. That's a big waste.
Yeah. When you saw it, it wasn't what you really needed when you asked for it.
What about the idea of doing testing without coding? That is to say, doing prototype testing and showing users and the other stakeholders Figma or something.
I love that. The best example that I know of that was a friend of mine at US Bank gave a presentation about how they went about developing their new phone app. And what they did was they drew out some designs with pencil, brought in actual bank customers, and asked them to use the pencil designs. The amount of money they saved on prototyping and the speed of feedback on that is incredible. Or just mock it up in PowerPoint or something. What's the lightest thing we can do to get feedback?
And you still need to have had those thinking discussions so that you're showing people the actual feature, not just some vague feature, because it's a vague feature that isn't actually the real thing. Then that testing loop with users is a waste of time. So it still should come after all of the really good thinking, like a pause before actually picking up the story to develop, because we can chuck it away if it's wrong.
Yeah, exactly. Stop trying to make things perfect. What's the thing that we can get feedback on? What's the fastest way we can get feedback on it so that we can throw it away as rapidly as possible? It's the outcome that matters and not the code. And so we'll try something that doesn't work, throw it away.
Bryan, I want to ask you how I might implement this approach. If I'm a product manager or a project manager at a client and my organization is insisting on outsourcing the development work to India because the cost per developer is lower, and my vendor says, yes, I can do all this stuff. So we pick somebody who sounds good. And then the dev team is not showing us their work. They're not involving us. We don't even know who they are. The first thing we get comes after 3 months and we look at it and it's all wrong. You find out that you can't trust your dev team, that they don't actually have the skills that they said that they did. What do you do?
If you're going through a large outsourcing company, I think I'm identifying your root cause right there. I'm not going to assume that they're all terrible, just the ones I've worked with. But what you could do is call some friends who have used them to find out what kind of experience they've had working with those people, to find out if they do actually deliver software the way they promised they're going to do. And then write the contract in such a way where it's like, hey, if I'm not getting workshop with me every week, then you're in violation and you're in breach. It's going to cost you this much money. Make sure that you're protected by the contract, because it really doesn't matter what their testing approach is if you're only getting feedback every 3 months.
Yeah, so the TDD approach assumes a few things. One of it assumes is that you have a combined team with all these skills, and it assumes that you have skilled developers and business people who care and who are working together. But what do you do when you can't trust your development team? Because that does happen.
Find the people that hired those people and convince them that they need better people.
So you can't do TDD if you can't trust your dev team.
So if you have control over that dev team, change the incentives and upskill teams. When we started doing this originally, nobody even knew how to test other than manually keyboard pounding. And it took time to upskill. But then once we got there, we were doing it way better than the people that were hired to do testing were doing, because they didn't have the same incentive structure we had. They reported to another company. It all comes down to what you're incentivized to do and what you're incentivized to learn. And that's a leadership thing. So you have to get leadership involved and understand what the right thing to do is and make sure they put the incentives in place to make sure the right things happen.
Yeah, it's unfortunately too often the case that leaders have bought this idea that developers are too expensive and we can get 5 developers in India for 1 developer in America. And all developers are the same, so therefore we're doing this. And that's extremely embarrassing and career limiting for them to admit that it's not working.
I wish we had smarter people leading engineering. How many people are running a Toyota factory don't know anything about building cars? But it could be that having people that actually know how to deliver software correctly means that they build teams that know how to deliver software correctly. Hire those people. I have a friend of mine who works for a company where their CTO is now the number one generator of defects, doesn't understand why testing is so important. And anytime someone tries to improve something, this leads to burnout because they're fighting the CTO. So how's that organization get better? They could fire the CTO and be better off. Not even replace him, just fire him. Unfortunately, you'd have to know a little bit about the stuff that you're doing to know if you're doing it correctly. So hire people who know how to do it correctly.
There's quite a lot of organizations these days who are saying our software is not our core competency. Sure, 99% of our income comes through our e-commerce and 99% of our stock comes through our logistics, warehousing, supply chain systems, but that's not our core competency. We're a retailer, so we should outsource all that stuff to people who are good at it.
They might be right, and that means that they don't actually have any custom software, and it's all off the shelf. Before I worked for Walmart, I worked for a company that supplied warehouse management systems. GM and Kmart hired us to make software changes to the software we sold them.
The thing is that if you don't have a competency in software engineering because you've outsourced it, then you're just a mark for all of these fraudulent people.
I'm not talking about hiring a company to write custom software for you. I'm saying buy a commodity solution. So my company doesn't write payroll software. My company doesn't write any of the HR software. It doesn't write any of the scheduling software. We didn't write our version control system. We just go and purchase a commodity solution. But if your business strategy depends on software that you can't just buy, then you're now a technology company.
Even the companies that say that they're going to get their HR software or they're going to use some SAP software, they have a big issue with integration. They have to integrate all of these packages and services. So they still need expertise in that integration.
Once you start getting into the size where you need SAP, you're probably a technology company.
I find it hard to imagine any company these days that's not really a technology company in there somewhere.
So if you have a custom solution, you either cross your fingers and hopefully you found somebody good to hire who's going to be a partner with you long-term for your business, because it's not going to be turnkey. Even if they solve all the business problems, you have to keep it secure. So you either find that or you become a technology company.
Look, if you can get some good cloud software that is not that hard to configure and maintain, great, fantastic, solves a lot of problems for you. But so often you're buying something from SAP or somebody else, and really all you bought was a toolkit with a bunch of modules, but you've got to assemble it all yourself. And there's so much configuration and custom code writing. Even if you implement SAP, it's remarkable. And to have this idea that we just outsource everything in our technology just makes you very vulnerable. So I would argue you should be investing in building your capability in your core technology, maybe not everything, maybe just the integration part of it. If you don't, you're going to be a sucker for it's shitty people.
If it's your core business, you really should own it.
All right. I think we better go to summaries. Donna, do you want to kick us off?
I will kick us off with summaries. We started off with you describing what test-driven development is, and also behavior-driven development is, like a higher level, broader, more kind of scenario-based. We dug into the details a bit about how to actually do this in teams. A lot of making sure that the team really understands what the requirement is, what the feature is, what needs to be built, including the logic in it and the fail states and all the things that can go wrong. And if you've done all that thinking, then you've got the stuff you need in order to write tests at the same time as you write code. You did talk about also making sure that as you deliver code, the tests go with them, because otherwise you're not delivering the code. And we talked a lot about independent, primarily manual testers and potentially elevating them to a position that's thinking up front. Because if they're doing detailed logical testing at the end, they can probably do detailed logical thinking at the beginning. And potentially not having a QA person, but having that QA skill in a whole team. And I know that as a designer, I do loads of QA. I do a lot of the logical thinking when I'm designing. I do manual testing towards an end, but I expect that it's all been thought about before. You also talked a lot about value stream mapping and being able to identify where there are blockers, holes, gaps. If you've got one manual tester at the end, as you said, the throughput is one.
I've measured the impact of having an external adversarial testing team, and it ain't good. It's universally bad, no matter how good you might feel about it. The numbers don't lie.
Yeah. What I was thinking about was how to implement this. So this is such a big change in the way people work, even today. It's not many people actually work like this. I think the dojo is probably the best way to teach a team how to work like this.
I agree, and I think we should define dojo for people. So the dojo process is where you've got people who know how to work this way, working with a team doing their daily work. So you're not going into a training session, you're just training, but you're using that team's work, that team's context to show that team how to deliver software better. I led a team for 4 years that did this. We would join your team for 6 weeks as team members, run you through 2.5-day sprints. You'd run 2 sprints a week, get really rapid feedback. You had to be able to demo every piece of work within 2.5 days. So you got good at breaking things down small. And universally, teams are always happier because they're already doing continuous integration. And it always makes a team's life better. But it takes a long time to learn how to do this without having skilled technical coaching helping you figure it out. I know because we had to learn it without any skilled technical coaching. So it's a big change. What we were doing in the dojo, about 2 or 3 weeks in, they'd start seeing how their lives are improving, and then they would start running with it. But before that, we had to get them over the hump. If you don't have that to get people over the hump, you have to have incentives. And our incentive we were given was we need to be able to deliver a lot better. We had an EVP say, I need you guys to figure this out.
All right, this has been really good. How can people find out more about this from you?
Come talk to me. I like talking about this stuff. I also tend to have conversations with people behind the scenes where they're trying to figure out some problem that's unique to their context. Come talk to me about it.
Yeah, so the people can contact you through LinkedIn. Is that the best way?
Yeah, LinkedIn's probably the best way. And also a couple of websites I want to plug. minimumcd.org, which is a project we put together a couple years ago at DevOps Enterprise Summit to help people jumpstart that. Another one is dojoconsortium.org, which is a bunch of playbooks that have been put together. There's a lot of really good information out there that has been battle tested on helping teams. And then the last one is my Scaled Agile DevOps Maturity Framework. You can go to sadmf.com because everybody needs a scaling framework to make money.
Yeah. I paid for my SADMF for the certification. So you got my money.
I do hope there's a t-shirt with that.
You can buy a t-shirt. Dave Farley has a t-shirt. He's an accredited facilitator. And you get all of the expected outcomes from the other more popular scaling frameworks at a much lower price point.
All right. Thanks very much for coming on, Bryan.
Thank you.
Thanks for having me.
That was No Nonsense Leadership from Murray Robinson and Donna Spencer. If you'd like to explore better ways to develop software products and services, contact Donna on LinkedIn and Murray at evolve.co. That's Evolve with a 0. Thanks for listening.